Hello, welcome back. So this is our last video of this chapter. I hope I have cleared all your doubts and concept in my previous videos, but still if you have any doubt or any question, you can put in comment box and I'll definitely clear your doubt. So let's begin the last topic and the last exercise of this chapter. So let's recall decimal expansion of rational and irrational number. After this, without performing actual division, you can easily identify whether the numbers are terminating or non-terminating. Let's see how it works. Rational number can be represented in P by Q form. You can see here that P and Q have no common factor other than 1, or you can say P and Q are co-primes. And if Q is in the form of 2 raised to power n, 5 raised to power m, that means if Q is having factors 2 or 5 or both, then only it's a terminating. Otherwise, if Q is having factor other than 2 and 5, then this will be non-terminating. And in case of irrational number, it cannot be represented in the form of P by Q. Exercise 1.4 NCERT, question number 1. Without actually performing the long division, state whether the following rational number will have terminating or non-terminating repeating decimal expansion. First part, 13 upon 3125. In this you have to check whether these two numbers are co-prime or not. Like in this case, it does not have any other common factor other than 1. Now you will do prime factorization of 3125. This is divisible by 5, 6 and 30 to the 10, then 5 5s are 25. Again, if you divide by 5, you will get 125. Again, this is divisible by 5, 25, 5. So the 3125 has factors in the form of 5 raised to power 5. Which means denominator is in the form of 5 raised to power 5. That means it's a terminating. Our next part is 17 upon 8. This is already in simplified form. So you can see here that denominator 8 is in the form of 2 into 2 into 2, which is 2 raised to power 3. So again, it's a terminating. Third part is 64 divided by 455. If you check, these two numbers are co-primes. Let's do prime factorization of 455. When you divide by 5, it's 9 and 1. Now you can see it's divisible by 7, 13, and 13 is a prime number, so it's 1. So prime factors of 455 is 5 into 7 into 13. Clearly it's not in the form of 5 and 2. That means this is non-terminating. Next part is 15 upon 1600. If you see they are not co-primes, you can divide it further, like both are divisible by 5. It's 3 and this will be 320. Now you will do prime factorization of 320. Is divisible by 2, 160 again. It's 80, 40, 20, 10, 5 and 5 ones are 5. So 320, factors of 320 are 1, 2, 3, 4, 5, 6. 2 raised to power 6 multiply by 5. You can see the prime factors are in the form of 2 and 5. That's why it's a
terminating. Next part, 29 divided by 343. These numbers are co-prime. Also 343 is cube of 7. So in this case it's non-terminating. Another part, 6th, 23 upon 2 raised to power 3 and 5 raised to power 2. Here the denominator is in the form of 2 and 5, so it's terminating. Next part, 129 upon 2 raised to power 2, 7 raised to power 5 and 5 raised to power 7. You can see the denominator has factor 7 other than 2 and 5, so this will be non-terminating because it should be in the form of 2 raised to power m and 5 raised to power n only. If it is in this form, so it is terminating, and otherwise it's a non-terminating. Now 8th part is 6 upon 15. They are not co-prime, divisible by 3. 2 upon 5. Denominator is in the form of 5, so it is terminating. Next part, 35 upon 50, and the last part is 77 upon 210. This one is divisible by 5. 7s are 35 and 5 10s are 50. Factors of 10 is 2 multiplied by 5, so it should be terminating. Next one is, this one is also divisible by 7. 7 3s are 21, 30. Prime factors of 30 are 2 into 5 into 3. So it has factor 3 other than 2 and 5, so this one is non-terminating. So you can see these type of questions are very easy without any division. It's very easy to answer whether the numbers are terminating or non-terminating. Basically depends on this. If the denominator is in this form, it is terminating, otherwise non-terminating. So this was our question number 1. Let's move to our second question. Question number 2. Write down the decimal expansion of those rational number in question number 1 above which have terminating decimal expansions. In question number 1, the parts which are highlighted with pink are having terminating decimal expansion. Now we have to write their decimal expansion also. Let's do it. First one, 13 upon 3125. 3125 is 5 raised to power 5. The easier way, I don't want to divide it this way because this will be very tedious for us. So easier one is, if you multiply this by 2 raised to power 5 and 2 raised to power 5 in numerator also, then you will get 5 into 2, 10, 10 raised to power 5. Also in numerator you will get 13 multiplied by 2 raised to power 5 is 32. So it's easy to multiply 13 and 32. Let's multiply them. 32 multiplied by 13. 6, 9, 1 and 4, 1, 6. In numerator you will get 4, 1, 6, and in denominator 10 raised to power 5 means 1, 2, 3, 4, 5 zeros. So decimal expansion of this number will be 0.00416. Point will come before 5 decimal place. In second part, 17 upon 8. In this case, it's easy to divide this way. You will write 8 into 2, 16, and then 0.0, 8 ones are 8. It's very easy this way. Then is 16, 4, then 0.0, 8 5s are 40. So in this case, decimal expansion is 2.123. 5. Next part, when we reduce it, this will become 3 upon 320. 320. 32 is 2 raised to power 5 and 10 is 2 multiplied by 5. You will write it as 2 raised to power 6 multiplied by 5. In order to make 10, you have to multiply by 5 raised to power 5. And in numerator also 5 raised to power 5. So this will be 3 multiplied by 5 raised to power 5. And in denominator 2 raised to power 6 multiplied by 5 raised to power 6. So 10 raised to power 6 will come in the denominator, and in numerator 3 multiplied by 5 raised to power 5, which is 3125. Okay, now you will multiply 3125 multiply by 3. So this will come, it's 9375 upon 10 raised to power 6. That means 1, 2, 3, 4, 5, 6 zeros. Final answer is 0.009375. Decimal will come before 6th place. And this is my rough work. Next part is 6 upon 15. 3 to the 6, 3 5 is 15. So you can directly write it as 0.4. Okay. Sixth part, 23 upon 2 raised to power 3 and 5 raised to power 2. In this you will multiply by 5 in numerator and 5 in denominator. So this will become 2 raised to power 3 and 5 raised to power 3. 23 multiplied by 5. Numerator is, when you multiply you will get 115, and in denominator it's 5 into 2, 10 raised to power 3. So 115 upon 1000, 0.115. Decimal expansion of 23 upon 2 raised to power 3, 5 raised to power 2 is this. Last, it's divisible by 5, so I'll write 5, 7, 35 and 10. 7 upon 10 is 0.7, so you can directly answer it. So these are the question in which it's your choice whether you want to do this way, then you can, but there is one more method which is based on law of exponent. Like in this case I'm using a rule. If both of them are having same powers, then using laws of exponent you can write it as 10 raised to power 5. So choice is typically yours whether you want to go this way or you want to use this rule. Because when in denominator we have 10, it's very easy to convert in decimal form.
Question number 3. The following real number have decimal expansion as given below. In each case, decide whether they are rational or not. If they are rational and of form p by q, what can you say about the prime factor of q?
In this question, first you have to check which of the following are rational number. Like in first part, you can say it is terminating. So that's why it's a rational number. Next one is 0.12012001200. This way, that means the number in this forms are irrational. I have already explained you in previous lecture. Irrational number. And third one is 43.123456789, and there is bar after decimal place, which means it's non-terminating but recurring. So definitely this one is also a rational number. Now you have to tell what will be the nature of its denominator q. Like in this case, q is in the form of 2 raised to power m and 5 raised to power n, where m and n are non-negative integer. because it's terminating, that's why this will be in the form of 2 raised to power m and 5 raised to power n. Next one, this one is irrational number, so definitely this cannot be represented in p by q form. Third part is also a rational number which has non-terminating but recurring. So its q is not in the form of 2 raised to power m and 5 raised to power m.
Thank you guys so much for watching my video till the end. And yes, we have finished our first chapter, real number, from NCERT. But yeah, I am planning to come up with more number of videos on real number. Especially there will be variety of questions based on like board point of view, exam point of view. And guys, stay tuned to my channel and keep posting your doubts. So I see you in my next series of trigonometry. Bye. Take care. Thank you.